Okay, so let's begin. This is the fourth video on it's been a long day, on the periodic table. And what I want to talk about are some of the nuts and bolts, or continue to talk about, are some of the nuts and bolts of the periodic table. As I was saying before, this unit on the periodic table is basically in two parts. Informational, tells you things about the periodic table, gives you knowledge. Again, I like to say if you don't know anything, you can't think about it. So it tells you what halogen is, it tells you what a transition element is, what metals are, nonmetals, metalloids, alkali earths. Why is it called alkali earth? What does the word alkali come from?
Arabic ash.
Excuse me?
Arabs from the word ash in Arabic.
What's ash? No, say it. This is good. I like this.
Alkali meaning.
All right, who are some, let's get some native Arabic speakers. No, I believe you guys, but yeah, it's like a... How do you say ash in Arabic?
Depends on the dialect.
All right. Depends on the dialect.
Maybe in 1,000 years, they would say.
Old, like.
So, alkali, what does that sound like in Arabic? We have a lot of Arabs in this class.
I'm thinking about how it could.
The word alkali, does that sound anything like ash?
No.
I think I'm pretty
You've heard it here first, guys. This is Gulf Arabic. Who's anybody from Egypt? No Egyptians.
I'm not at all.
Oh, we just had a slight. We had a Arabic fight just for a moment. What was it? Yes.
The Egyptian dialect even further.
All right. Is that like an ethnic slur, or that's okay? You said it. That was okay. What you said? I don't know. Said something terrible about. Yeah. So what about like Levant? Any Syrians or Iraqis?
Sabah just left.
Where's Sabah from?
Syria.
Yeah.
Syria.
He's Syrian.
Are you Syrian, Jad? Where are you from? Lebanon. So alkali. Does it mean anything to you?
As they've said before, it differs in different countries.
No one's speaking
But in the
literal.
Maybe in like the old
Everyone has their
Arabic.
dialect.
no, up to the old Arabic. Come on.
Oh my God!
I know, I had a little piece of thing coming away. Okay. That makes perfect sense. Okay. Is that all right? Is there something in my eyes? Okay. So, anyway, what does it mean again? Could you say it loudly? You said, it said something in the book. It comes from Arabic alkali, meaning
The ashes.
ashes, something with ashes. Well, again, it means something with ashes, something from Arabic, but I have a lot of native Arabic speakers in here, and nobody has any idea what they're talking about.
It does not come from an Arabic word.
It doesn't come from an Arabic word. Okay.
167.
Yeah, maybe it needs to be right.
Okay, and it means what again? Let's do this. Victoria, what does it mean again?
The ashes.
The ashes. Alkali means the ashes. So what it means to us in the 21st century is in chemistry is that it's a solution that contains excess quantities of the OH negative 1 ion, otherwise called the hydroxide ion. 14 of a pH. 14 is the most basic. That is basic. Anybody know the word basic? Raise your hand. Okay, they're all slowly raising their hand. Basic, okay. Alkali is the same as basic, same thing. Okay, alkali. Something is alkali means that if I take the metal, such as the alkali metals or the alkali earth metals, and I do a chemical reaction, and it will form like sodium in water, gives off hydrogen gas, molecular, and I form sodium hydroxide, lithium hydroxide, potassium hydroxide all the way down. Magnesium, I can actually burn magnesium in air. And I form magnesium oxide. Old movies where you have that flash, that pan flash, where you have the smoke, a very bright flash. Old movies when cameras first came out. That was magnesium powder burning in the presence of oxygen, creates this utter white hot flame. Sparklers, magnesium. And that forms magnesium oxide. If I take magnesium oxide and put it into water, I form something called magnesium hydroxide, which is basic. People take it for constipation, magnesium hydroxide, or acid indigestion, constipation, loosens the bowels, and it is called magnesium hydroxide. Okay, so when we do the production of magnesium hydroxide, you can go home and say, Mom and Dad, today we made a laxative in class. Excellent. We're not going to take that any farther than what I just said. Okay, a laxative in class. We did something that makes the bowels operate more thoroughly. Okay, now, so this is what we're doing. We're introducing the nuts and bolts of the periodic table. You can see that I could speak about the periodic table for hours. I could tell you all kinds of stories about elements. I could tell you how elements are named, what Na means. Instead of saying Na, why don't they say So for sodium?
Because it's in a different
Potassium. Some, yes, that's part of it. Some is Latin, etc. However, some elements are named after people. Some elements are named after countries. Probably to me, one of the most well-known examples of an element that's named after a country is polonium, named after Poland, in memory of who?
The president of Poland?
The president of Poland. No, that is incorrect, but thank you for playing. Yes?
A famous scientist?
A famous scientist, that would be an understatement. So why doesn't somebody look up, Alec, look up the naming of polonium. Why is it named polonium? And you can get back to me on that in a moment. Okay, so what I did, Hadi,
Francium is also right.
maybe you'd have to look that up. Francium, is that named after France or Mr. France? Or Mr. Francium? Who knows? Let's look that up too. Why don't you, Mr. Hadi, why don't you look that up? Now, what we're going to do, I gave all my students, what's the time? I gave my students topics in the periodic table to look up, and we're going to feed those things to you as I continue with our journey through the periodic table. So, another aspect of the periodic table, yes?
The polonium is named after Marie Curie.
Marie Curie.
Curie, who is a Polish naturalized French physicist and chemist.
She was a
And
C-U-R-I-E, is that correct? Yeah, Madame Curie.
aren't they French?
Yeah.
She was not French.
Oh, didn't she have a husband who worked with her?
She was a Polish, and then she was a French physicist and chemist, but she was from Poland.
And did
She was
get
from Poland.
Yeah.
Did
Yes.
she get like a burn from uranium or something?
She died of radiation.
Well, why don't you look that up? I mean, she did have a husband, yes, but I don't want to tell you much about the husband. I want you to tell me about the husband, but not at this point. So let's talk a little bit about, when you look at the periodic table, you're going to focus in on the center of the periodic table. And at the center of the periodic table is a group of elements, a group of metals known as the transition elements. Now, so who's doing transition elements here? So you're doing transition elements. What can you tell me? What can you tell me about transition elements? Anything over here? Let's see.
Well, good question.
Good question. Excellent. Thank you.
I can tell you a lot about transition metals. They are from the group B elements, and
They're group B elements. That's the American version.
Yes.
When you say B elements, that's like an American thing. America always has to do things very weird. Okay? First of all, to me, that's always been confusing. B elements, A elements. I like the European model where you just simply 1 through 18. But these are B's, these are A's, these are A's. The S and P's are A's, these are B's. Go figure. But that's what she's referring to. So being, okay, yes. When you think of, let me tell you something, when you think of a metal, when I say the word metal to you, what's the first thing you think of?
Iron. Steel.
Virus?
Iron.
Iron. Iron, right, iron, right? That might be what I think of too. What else do you think of?
Magnetic.
Magnetic.
Hard.
What is it?
Hard.
Hard. What else? When you think of the word metal? Shiny. That's what I think of when I think of the word metal. The first thing I think of is shiny. Okay? When you think of metal, really what you're thinking of, usually, normally, you're thinking of a transition element. Notice you said transition metals. They're actually transition elements, but they're metals, so we could say transition metals because it's a type of metal. So the transition metals, the transition elements, are essentially what I think of when I think of a metal. When I think of a metal, I don't think of sodium, which is like vanilla Turkish taffy. You know, it's you can press it and squeaky, you know, etc. Yeah. And gold. When you think of gold, gold is not what you wear. Gold, that's only part gold. If you produced rings and pendants in pure gold, they'd fall apart. Yes.
No, I was just going to say that they would fall apart.
Yes, they'd fall apart. Excellent. Yes. Gabby, continue.
Okay. So in the atoms of transition metals, the highest occupied S sublevel and D sublevel contain electrons.
Yes. Yes. Now one thing you don't want to do is you want to talk to me as if you're having a conversation with me when you talk to me about these things. You don't want to read from the text. That's a little boring, don't you think? You want to put in your own words, yeah? And everybody wants to contribute something, yeah? So should be able to beat you off with a stick. You should be like throwing things out at me. But if you look at the transition elements, the valence, the outer electrons are actually the S's. So in other words, if I take gold, Au, gold, right? If you look at the long form electron configuration, the short form electron configuration, it's going to be xenon and then 6s2, 4f, 14, and then 5d9, right? So you see that the S, remember I said the S and P electrons are the valence electrons? Well, they all have the same S valence electrons. Now, in reality though, gold has how many S electrons in its natural state? It's here. It's only one away from being half full, so it's going to steal one, and so it's going to be 5d10 6s1, right? Yes? 4f14 in there also, but so you're going to, it's not going to be 6s2, 4f14, 5d9. You get that stealing of that S subshell electron. What else? Alec, anything? You guys, are we done with transition elements? I hope not.
No.
Anybody else? Yes. What do you want to say?
Me?
Anybody?
Do you want to?
Okay. We'll get back to transition elements.
Well, we have them.
Yes, I understand that, but I want to be, you guys are a little too exciting today. I mean, I'm a little on edge. You guys are so lively, you want to, relax a little bit. I know, he's a fun guy, okay? So anybody else? Yes?
You told me to search about francium.
Francium, yes. We got to report on francium.
Yeah, it was named after the country France.
It was named after the country France. Another example of an element named after a country. What else do you have?
Discovered by Margaret Catherine Perry.
I'm sorry?
Discovered by Margaret Catherine Perry.
It was discovered by Margaret Catherine Perry.
Yes.
How do you spell that?
P-E-R-E-Y.
P-E-R-E-Y. Excellent. Now, what else did we say? Yes?
Don't transition metals have more than one name? Like there's copper 1, copper 2, copper 3.
They have one name, but They only have one name. Gold is gold. Yes, it's called other things. It could be called other things. But what you're referring to is that transition elements oftentimes have more than one what we will learn as being an oxidation number. Clear?
Yes, sir.
In other words, they obtain a charge, +1 or 1 minus, or 1 plus. I say +1. I make it like an integer. So, but some of them only have one. You know, like zinc has +2, usually always. Cadmium is usually always +2, etc. So oftentimes they have multiple oxidation states. I think I actually may say that in the book. But I don't really want to talk a lot about oxidation states. We will talk a little bit about it. But just suffice it to say that transition elements have multiple oxidation states. In other words, they can form a lot of compounds. And what you may be referring to are iron 3 oxide and iron 2 oxide. Okay? When blood, I think we talked about this in one of the other videos. It's a little confusing, maybe because I have 3 sections of chem and I've made videos in each of the classes now. Blood. When blood dries out, it turns dark brown. When blood is in the body, it's red. It has oxygen in it. When it loses that oxygen, it turns to change its oxidation state. So red blood is going to be +3, and brown blood is going to be +2. That's why they put, I think I mentioned this, that's why they put something called, a chemical called sodium nitrate into prepared meats to give iron that characteristic +3 red state, so it looks a little bit more appetizing. Brown bologna would be kind of gross. Yeah. Anybody else? Okay, so what else? What did you have? What topic? What is it? I can't hear you.
Non-metals.
Non-metals. Excellent. Thank you, Red. What can you tell us about non-metals? You and Kaylee, right, had non-metals, right?
Yeah.
And those, you two. Okay, tell me about non-metals. Let's demonstrate how to do it, guys. Okay, what do we got? Non-metals.
They're poor conductors of heat and electric currents.
Poor conductor of heat and electric currents. That's actually quite true. Very true. Like oxygen, for instance. Can you imagine? You know, conducting electricity using oxygen?
Nope.
A little weird, yeah. Carbon dioxide, when you bond them together, still not a good conductor of electricity. Yes? Yes?
So they're basically the opposite of the transition elements.
Are they the opposite of transition elements? Yeah, pretty much. I mean, transition elements will give up electrons and become positively charged. That's actually a definition of a metal. If I could define a metal in one sentence or less, a metal is an element that gives up electrons to become stable and forms a cation. A cation
Positive.
is a positively charged ion. An anion
Negatively
is a
charged.
negatively charged ion. You may remember that from cathode and anode. What else? What else you got there? What else do we have?
They're mostly on the right side
They're on the right side.
because they're stable.
Yeah, they're fairly stable, exactly. Okay, yeah, they're very close to being stable. Well, sodium is close to being stable too, but we'll talk about that in a minute. So along this line, this red line, see that step stair line? Those are metalloids. They're kind of metal, non-metals. And these are the non-metals. These are the non-metals, all this, non-metals. Okay? Yes? Metals are over here. Okay? And there's three or four major areas. There's the alkali earth metals, alkali earth metals, transition metals, the rare earth metals down here, inner transition metals. I think they give a example of what the periodic table used to look like in the 20th century when Glenn Seaborg took these inner transition elements out of the table. if you shift all this over, put these in here, and there's nothing above them, that was what the periodic table looked like. Matter of fact, a lot of Glenn Seaborg's colleagues said, don't do it, Glenn. Don't publish that paper on putting the inner transition elements down there. You'll lose your career. You'll become a laughing stock. It'll ruin you. And he got a Nobel Prize from it. So it was actually a good thing that he did. Anyway, what else you got? Non-metals. Yes, Kaylee.
They're highly, well, they're easily vaporized.
What is it?
They're easily vaporized.
They're easily vaporized. Now, are these the elements or the compounds that the elements make?
The compound.
All right, I'll hold off on that. Anything else there, Mr. Hadi?
There's
They have low density and melting points.
Low density, low melting points. Okay. Meaning at room temperature, what are they generally?
Yes.
Gaseous, yeah, very good. Is that what you meant?
Yeah.
That might be what you meant. Very good. Excellent.
And those have high ionization energy.
Yes, they have high ionization energy because what's the ionization energy? What does it mean, ionization energy?
Amount of energy it takes to move.
What is it? What's ionization energy?
Energy needed to move an electron from the LX.
Yes. The last electron you put in other words, the electron that you write the 4 quantum numbers about, the last electron in the electron configuration, the energy needed to remove that electron. So therefore, it's the energy needed to make the element, the atom, a cation, right? Yes? Do nonmetals normally become cations? No. They normally become anions. That's very good. So they easily accept an electron, don't they? But they hold on to those, whatever it has, so it would be much harder to remove an electron from a nonmetal. So you're right, they would have very high ionization energies. Okay, anything else with that? I'm going to stop there. I'm going to stop there and we'll pick this up the next class. Now you know what topics you have. We could probably finish it the next class, yeah? And I want to start on the ionization energy lab. I want you to actually maybe start scratching out the graph. It may take you 3 or 4 tries to get it going. It may take some planning. I'll give you some hints. All right, are we clear on that?
Yes.
All right, we done?
Yes.
Excellent. Part 4, periodic table introduction. Was that exciting? Are you excited?
Mr. Icer, we haven't gotten the packet